Hey everyone, Houston Math Prep here. We want to introduce an arithmetic sequence. I know this looks like the word arithmetic. Arithmetic, we pronounce it that way when it's a noun in our language. When it's an adjective to describe what kind of sequence we're using, we pronounce it arithmetic. So an arithmetic sequence is recognized by a pattern of adding the same amount to get from one term to the next in your list in a sequence. So if I've got my example here of 1, 3, 5, 7, 9, odd numbers, you can probably look at this list and see the pattern going from one term to the next is that we're simply adding 2 to get from the first to the second and from the second to the third, etc. So if we're going to consider a sequence to be arithmetic, we need to be able to take any term, like 5, and subtract the term before it and get that difference, okay? And this value is called the common difference because it's the same amount of difference between each term and the next. 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2. So we can say that here our common difference is 2 and that this is definitely an arithmetic sequence. Here, let's just look at some examples and decide if they're arithmetic. So we're going to find the pattern, and if we find the pattern and that it's arithmetic, then we'll go ahead and state what the common difference is. So for the first one, I have 5, 15, 25, 35, 45. By the time I got done reading that list, you probably already figure out that the pattern is we are going up by 10 each time, right? I'm adding 10 to get from 5 to 15, and then 15 to 25, 25 to 35, and 35 to 45. So is it arithmetic? Yes, it is arithmetic. And we'll go ahead and say that our common difference is 10. I'm going to go ahead and use D for common difference. So my common difference is 10 for this one. For the next one, 1, 3, 6, 10, 15. You might see a pattern here, and that's cool. The question is it arithmetic? Do we go up by the same amount each time? And the answer is no. Here I go up by 2, but then the next time I go up by 3. And already I don't even need to look any further because I already know I'm not going up by the same amount each time. So you can keep saying, oh, but there is a pattern. Here it's plus 4 and plus 5. Yes, but the question is, do we have a common difference? In other words, when I take any term, subtract the term before it, do I always get the same amount? And the answer is no. There's not a common difference, so this is not arithmetic. Okay, next one, 30, 27, 24, 21, 18, etc. If we look here, you can probably see that the pattern is that we're going down by 3 each time, right? So, do we have a common difference? And the answer is yes, we do have a common difference. If we are adding or subtracting the same amount, then we can consider that to be a common difference, right? When I take 27 minus 30, I get negative 3. When I take 24 minus 27, I get negative 3, etc. So yes, this is arithmetic. And our common difference here is negative 3. For the next one, 1, 5, 25, 125, 625, there is a pattern of multiplying, right? 1 times 5 is this, and if I multiply this by 5, I get the next one, and multiply this by 5, I get the next one. But the pattern for arithmetic sequences is a common difference, right? Do I take 5 minus 1 and get the same thing as 25 minus 5, right? And the answer is no. If I take 5 minus 1, then that just gives me 4. If I take 25 minus 5, that gives me 20. I don't get the same thing when I subtract. Difference meaning subtract, right? Here I get 100. So definitely not the same thing when I subtract a term with the term before it. So that is not arithmetic. This one here, it looks close. Here I go, well, 1 and negative 1, they're 2 apart, and negative 1 and 1 are also 2 apart. And so we just kind of get this thing that's 2 apart on down the line. If we think about actually doing the subtract to get the difference at each step though, negative 1 minus the term before it, negative 1 minus 1 gives me negative 2. So the change there is negative 2. 1 minus negative 1, which is like plus 1, actually gives me a positive 2. So here I'm changing by going, so here I'm subtracting by 2 to get to that one. Here I'm adding by 2 to get to the other one. So we don't get the same difference, right? Same thing here. 1 to negative 1 will be like this. This is a negative 2, and then this would be a positive 2 again. So we're getting this alternating change. It's close, but not really what we're looking for arithmetic sequences. The formula for an arithmetic sequence can be written like this. we have a sub n equals a sub 1 plus n minus 1 times d. Just some anatomy of this here. So a sub n being any term, if you want to find any term, then it'll be equal to the first term plus, we have the quantity n minus 1. Remember, n is just your term number, so this is the term number minus 1 in here, and then d is your common difference. So any term equals the first term plus n minus 1 times the common difference. Let's go ahead and write an explicit formula based on this for arithmetic sequences and just get practice doing this. So here I have 4, 9, 14, 19, 24. This is arithmetic, and we might notice that we are adding 5 each time to get from one term to the next. And so that tells us right away that our common difference is 5, right? So if I'm writing this formula, a sub n equals my first term in this one is 4, plus n minus 1 times my common difference, and my common difference is 5. Now we might want to do a bit of simplifying with this. If we go ahead and distribute the 5, then we might get 4 plus 5n minus 5. And then we could go ahead and rewrite that combining like terms, and we could go ahead and say that a sub n is 5n minus 1 if we prefer. Let's look at the second one here. I've got 28, 22, 16, 10, 4. We are going down by 6 each time, so it's minus 6 for our common difference. Negative 6. If I take any term and subtract the term before, I get negative 6. So for this one, a sub n equals a1. My first term is 28. That's included in the formula. Plus n minus 1 times my common difference, which is negative 6. I could distribute the negative 6 if I prefer and say 28 minus 6n plus 6, and then go ahead and combine like terms here, and we could say a sub n is equal to negative 6n plus 34. Okay, let's look at our last one here. 1/6, 1/3, 1/2, 2/3, 5/6. You might stare at this for a minute and say, what in the world is going on with this one? I can't tell that this is even arithmetic. It's in the video, so I guess we're saying it is, right? So what you could do here, I think, the nicest way to see this, these are all reduced because we were nice and polite and reduced them for you. The problem is that reduction created a pattern we might not be able to see. So if I sort of unreduce these, right, and think of all of the denominators being over 6, 1/3 came from 2 over 6. 1/2 came from 3 over 6 before I reduced it. 2/3 is 4 over 6. And now that we can see everything in a non-reduced format, it might be easier to figure out what's going on. So how much am I going up by each time? Well, my common difference here, I'm going up by 1/6 each time. 1/6, then 2/6, then 3/6, etc. That's my common difference, right? So for this one, our a sub n formula is going to be the first term, which is 1 over 6, plus n minus 1 goes in my formula, so n minus 1 times the common difference, which is 1/6. We can go ahead and distribute like we did before. 1/6 plus 1/6 n minus 1/6. And you might notice that the plus 1/6 and the minus 1/6 really become 0 when we add them together. So really, we just get a formula of a sub n equals 1 over 6 times n for this one. Okay, hopefully that gives you a good start on arithmetic sequences. We hope to catch you in the next video. See you then.